Okay, good evening, everybody. Thank you for those of you that are joining us directly tonight. This is actually amazing. It's the first hybrid meeting. We're hoping that it's going to be a great success. And definitely we're going to be trying to do this from now on, things that the restrictions are a little bit less. And I think this is so much better for everybody involved. Okay, so just a quick rundown of upcoming events. And first of all, apologies also from Dean. Dean couldn't make it tonight. He's got a personal emergency, so he asked me to step in for him. Okay, upcoming events. Next month, we've got the Turk Banner on the 9th of June. At this stage, I don't know if it's also going to be a hybrid meeting, but that will be communicated to everybody in due course. Okay, then just a notification also. Our golf day this year will definitely be going on. We are going to be having that on the 8th of October. Anybody interested in doing 4-ball or a watering hole or whatever, I'm not sure what the restrictions there will be at this stage. Please get in contact with either Cheryl or myself. Okay, and then for the ladies, we are going to be doing a ladies event on the 20th of August. At this stage, it looks like we're going to be doing at the Sandton Indaba Hotel, and more will follow on the information there. And then also coming up on the 26th of May, we are going to be doing our first virtual training session. At this stage, I'm also not sure whether we're going to be doing that as a hybrid session, and that will be done by Schneider Electrical. So we'll give you more information closer to the time. All right, so I'm going to ask first of all, so everybody that is attending virtually, please to make sure that their cameras are turned off and that everybody is muted. Okay. For the guys that are sitting here, if you've got questions, please raise your hand. We will definitely attend to the questions as we go along. For anybody attending virtually, also please just put up your hand or put your question in the question box, and between Lawrence and myself, we will actually ask the questions so that Dave can answer directly. So then I'm going to now be handing over to Dave Wibberley from Adroit, who is doing our presentation tonight. Dave, first of all, thank you very much for doing this for us. We really appreciate it. And thank you for being our guinea pig tonight with the whole hybrid situation. We haven't tried this before, so we're hoping everything's going to run nice and smoothly. Dave is going to be talking to us a bit about machine to machine and specifically discussing the M2M and IoT landscape and technologies. Is that correct? So thank you very much. And Dave, with that, I give over to you. Thank you, everyone.
In the right place. Guys, I hope you can hear me there. I'm going to, this is a bit interesting from a point of view that it is hybrid, from a point of view that we have about 15 or 20 people in the audience, and I think we have about 25 or 30 people online. So I think this is definitely going to be the future of these types of presentations. So I was asked a week ago, I think there was a cancellation, and I was asked to step in. So what we're going to show you today is some stuff that we were working on quite. We've been almost released. In fact, we are released on it. So I'll give that as part of the demo. But I think what's going to be interesting is to talk about the technologies, which is machine to machine and IoT, as well as remote monitoring, and that whole sort of spectrum of technology. So we can step forward on the, oh, no, sorry, I have a, excuse me. Might work. Give me a second.
Don't push buttons. Give me 2 seconds. Okay.
All right. Okay. So we're ready to go. So can I step forward? There we go. All right. So I've already spoken about this, the landscape of IoT, IoT if you want to, and I think that's where we're going to go. So for those who have seen my previous presentations, it really is, what is this IoT thing coming about? What is allowing us to be able to start monitoring remote stuff relatively easily, and what is behind the whole thing? And there are three, I always see it as the coming together of three laws. You probably understand Moore's law. Moore's law is the density of integrated circuits on chips is doubled. That means there's more processing capability on a chip size per square meter, if you want to. Metcalfe's law which talks about the states of a network, and that a network's value is proportional to the square of the number of users. So we all know that we're all on GSM networks. We're all connected to the internet. So the value of these networks, in fact, goes up as a square of the number of connections. So the more devices connected, the more value the data exists, the more value to humanity, so to speak. Then, of course, there's something called Kumi's law, which is a relatively new one, which talks about the fact that computation per kilowatt hour has increased by a factor of 1.5 per year. So in other words, the power consumption relative to the amount of amount of processing you can do has dropped significantly. So the perfect storm there allows for what we call the LP-WAN technology, if you want to, which allows us to put chips that do more at source, at lower power, and are connected to more valuable internet networks. So that's what's allowed this thing. It's nothing clever. And if you look at this slide, it really tells you that you can see on the left-hand side, Moore's law. You can see now transistors per square centimeter or something. I'm not quite sure what that is. You can see the value of networks. You can see two computers connected together. That's one. And you can see the connections in terms of value. And then at the moment, if you go in terms of interconnectivity, then of course Kumi's law allows from 1940 to 2010. You can see that in fact the processing power has gone up significantly. So what we can do on a small chip now, powered by a battery that lasts 2 years, is probably what they sent the rocket to the moon with. From a systems perspective, I always liked studying the guy called Russell Ackoff, who tried to define. We've all talked about this hierarchy. From the bottom, data, information, knowledge, understanding, and wisdom. We've all seen that. And he actually spent a lot of time trying to define what that means in the real world. So at the bottom, data is raw elements. So those are, I'll give you his definition now, but that's the value of a temperature. That's the value of a state of a motor, all those sorts of things. But what's really more important here is the fact that he defines the value of the hierarchy as each level is 10 times more value than the previous level. So if you can get to the information stage, it's 10 times the value of the data. And likewise, if you go all the way up to the top, so in fact, wisdom, if you get to the top, it's 10,000 times the value of the underlying data. Okay, so 10,000 times the value. And I'll show you where we are now, where I believe we are. So this is just two definitions that he came up with at the lowest level of that hierarchy, where data and information we talk about, where in fact data is defined of symbols that represent objects, events, and their properties. So they're products of observation. Is the motor running? What is the temperature? How many people? Or what is the pressure? That's data. If you can answer questions of who, what, when, and how many, that's information. So that's typically you put that data into a database, and it might be relational, and you can say, for example, how many times did the temperature exceed the set point? That's information. And we're still only on the second tier of that hierarchy. So if you look at it before we get too excited, generally, and even to this day, we are still sitting at the information age. I'm not going through the other definitions. You can Google that, and that's for a different talk. But we are still sitting there. But what's key here is the fact that information and data is becoming, with IoT, becoming so valuable to that hierarchy to allow it to push us up that chain. So the more data you have and the more data you can process into information and knowledge, and as tech drives us up that, the more value that data is going to be. And this is what monitoring and machine monitoring is all about. So I always talk about context here, and of course context comes because the world is not single dimensional. The temperature of something is usually a function of a whole bunch of other stuff, flow rate, how much power you're putting into it, what the material's going in the pipe, what you're boiling, all that sort of, how much energy you're putting into it, etc., etc. So the world is a multi-dimensional world. It's not a single-dimensional world. So I always show this, and I show that slide, and I ask the question, is my dog sick? He looks pretty sick. Okay. But if you go to the vet and he takes some blood and he does some processing of that and he gives you this, can you tell me if my dog's sick? No, you can't. So unless you're a vet, that means nothing to anyone. However, if he just overlays that to it, we're all geniuses. Because we can straight away see what the levels are supposed to be, where my dog is sitting, and what the limits are. So just that alone is the value of context. The data, pretty hopeless to the uninformed. However, overlaying very simple context to it makes that value of that data very large. So if we look at the landscape of remote monitoring, if you want to, it really is defined, and that there's no real good choice of technology. The choice of the technology is there to fit the application. I think that's key. And again, there's no golden thread amongst this lot. So if you look at proximity, if you're looking at 10 meters, NFC, RFID, we're all familiar with those technologies. It's your banking card. When you tap your banking card, it's using NFC. Okay. RFID, we're all familiar with that as well. If you want to now move away a little bit, 100 meters, there's a plethora of technologies, Zigbee, ANT, if anybody does cycling, ANT is the technology that picks up your sensors from your power meters and other bits and pieces, maybe Bluetooth, but ANT is that. If you need to go to 1,000 meters, what is my choice of technology? Because those don't work anymore. You now need to go to Wi-Fi or to Wi-Fi essentially. If you now need to go to metropolitan areas, move into the 10 kilometer range. WiMAX, Zigbee will work. But if you now want to go into really remote monitoring where a farmer wants to monitor something in the middle of nowhere, up to 100 kilometers, you need to move into the LPWAN space, which is either using, I mean, obviously there's NB-IoT, there's other technologies that the telcos use, but the generic stuff, the other stuff are things like Sickfox, LoRa, and LTE. So it really is a choice of what you're trying to monitor from where, and there's trade-offs all along, and I'll tell you about that there. So if you look at just monitoring, if you want to have low data rates, know that you want to monitor small amounts of data, very high reach, very little control. Something like Sigfox is a perfect network and a perfect technology. I've
noticed that Anglo-American, we've been doing a lot of tenders for them of late, and Sigfox and LoRa are the two that they
keep the question for later. Okay. I think we'll answer it for everybody. That's a good question. Again, Sigfox is a network supplied by a service provider. Whereas LoRa, you make your own private network. You can piggyback off and pay them, but it's largely private networks as opposed to a single community of networks, which is something like Sigfox can provide. If you want to do monitoring and control, you need to more, because Sigfox is very limited in the amount of data that you can send. Typically, you can only, the maximum rate you can send, or the maximum amount of data you can use for Sigfox is about 5 Modbus registers every 10 minutes. That's the best you're going to get out of a Sigfox network, because their network has been designed for millions of devices, small amounts of information. And of course, it's not bidirectional. So that's where the power comes from. It wakes up, transmits, goes to sleep again. That's where you get the power saving from, but it can reach through buildings, through levels, and it's a very good network from that perspective. But you can't do control. If you need to now move into monitoring and control, you need to look at something where it's reasonably low data, high reach, some control, things like LoRa, IoT, Android Connect is one of those products that sit and use GSM, in fact, to achieve. And again, medium data, high reach, local control, something like a PLC. And again, by the way, these do mix across these functional requirements. MQTT, that's just a transport, it's a protocol. And then something like our Android M2M, where we built some telemetry type protocol that works on the GSM network, which allows you to do local control of a machine, but to get that machine's data very easily onto the cloud and have bidirectional, almost working like a SCADA, or almost working like a normal control system where you've got your SCADA in the control room. In fact, it works really, really well from the cloud. So we've done a lot of work around that. And some examples are, we've got a customer doing chlorine dosing plants. They put them anywhere. And again, if anybody's worked in this game, the biggest challenge is working within the networks. If at the moment you have to go GSM, you have to work with the likes of the Vodacoms or the MTNs, which is a challenge by itself. Or you then have to, like Polar have done, have their own APN or their own relationship where they've now shipped you SIM cards. Whereas that solution we built specifically where you can put any data SIM card in your PLC and it'll work anywhere in the world, back to a single host. And then, of course, full telemetry, as we know it, the likes of Johannesburg Water, these guys have dedicated radio networks that are, but a lot of the RTU manufacturers do offer GSM, and obviously 5G is coming down the road as well, which will give you very, very fast control. But again, my experience is it's very difficult to do business at a small scale with the big telcos of the world. That's very difficult. So I'm not sure how they're going to crack that. The tech is there, but it's going to be interesting to see how that plays out. The advantage, of course, of something like Sickbox is, and I'll just tell you briefly about Sickbox because I think it's worthwhile discussing. If you look globally, they're in 72 countries. They cover 5.8 million square kilometers, 1.3 billion people covered, and they're handling about 30 million messages a day. In South Africa, they cover about 90% of our population, about 52 million people covered by Sickbox. So one of the products that I have, another business, is the Poolsense product that uses Sickbox, where it's again every 2 or 3 hours we transmit. You drop a floater in your pool, it transmits that to the network. We pick it up and then we process that and give it back on an app. Perfect for that. Very low power. That device will last 2 years, and that's really what it's good. The other one, of course, is something like this, and I'll show this to you. Like, for example, we've just installed, I think, 20 of these. Aiden? 15 of these, and it's an ultrasonic. Again, it mounts onto whatever you need to do, measure up to 3 to 5 meters, I think, and will transmit. It transmits the level, in fact, in flues for early flood monitoring. The problem, of course, is that we've had 5 stolen in 2 weeks. No, it's really, really sad. It's sad. It's really sad. It's a different story. Right, so we were there. So if you look at that slide, this is the Sickbox coverage. And the nice thing about Sickbox, if you've got a device, and there's a community of people that can make devices, that device you can pick up and you can sell anywhere in its own radio zone. So Europe, for example, and South Africa, all in RC, what they call RC1. If you buy a device off the internet, RC1, you can bring it to this country, it will work. It's certified, they're cheap, and they can achieve the basic monitoring. So it's a really nice community from that perspective with lots of devices. Whereas if you go and try and find a device that is NB-IoT, you're going to battle. That's the value of something like Sickbox, but it is limited in the amount of data it can transmit. That's the coverage of Sickbox in Southern Africa.
Say, just give a second, please. Your slide is not correct on the virtual meeting. Sorry.
Where are you? Which one are you on? Just a second, guys. Yeah, I'll keep talking while I look at the check, but Sickbox is covered in Namibia, Botswana, and South Africa, and it really has worked pretty well. That we've noted for a lot of customers monitoring basic small stuff. It's not working.
Just give us 2 seconds.
Give us a second, guys. Is it working?
It's black at the moment.
Maybe point your screen at Lawrence. No, I mean, so let's say Lawrence can see. No.
Are you?
So black.
Okay, tell me when it's going over to
Hang on.
the cam.
Okay, you can see Dave now.
Mhm.
I don't mind being the guinea pig here. No.
There we go.
Okay.
Have you got it? So you've got that. Okay, fine. So I'm not sure how many slides we missed, but there is the coverage around South Africa and Namibia and Botswana. Okay, and as I said, the key benefits of something like Sickfox is that you can go onto the website and there are a lot of local manufacturers of devices.
And we still haven't got the release file.
There's a delay. The slide didn't begin.
Just ask if the rest of the people has got the new slide.
Okay, once we can close the video if we keep to that bandwidth.
We can.
Turn me off.
We can. Okay.
They say they can still see the SMA coverage map, which is actually what I can see.
Hold on. I'm just going to stop and start it again.
Technology, love it and
Yeah, I mean, if you think what we're doing here, it's actually remarkable that we're sending live video to 30 people in the, I mean, in the camera time.
As soon as you see something.
So Dave, those certified sensors, those are people that are manufacturing items and selling them with Sigfox.
You can go into the Sickfox website, look for products, search for products, locate a supplier, order from him, bring it down here, register on your account, and it'll work.
Okay, don't worry about the cam now. It's all on the presentation.
Okay, good. So that's the nice thing about Sickfox, and you can, and of course that's a very competitive space to be in the sensor world. But there's you can monitor everything. And for example, that there is to monitor if there are cars in a parking space. I know that one, but it's there's air quality. There is 4 to 20 milliamps. There's power. There's whatever you want to monitor. Generally, someone built the sensor. So we've got a sensor that monitors 0 to 20 bar of pressure in a water tank and transmits every 15 minutes. And so people can put these on pipelines running in the middle of nowhere. That's the advantage. No power requirements, no infrastructure. You don't have to put in any solar infrastructure, which generally gets stolen and vandalized. You can put, and you can literally bury the little, this is IP68, you can literally put that in the ground and it'll transmit, so you can get away with it. All right, so I'm going to demo Sickfox very quickly. Let's just take a little break and show a bit of live stuff. So Lawrence is going to go on to that demo IoT one.
2 seconds.
Stop showing.
He's going to have to put the video, the camera back on now.
I need to change.
No, you don't. Okay, let's try it. So we're just connecting to our Droid server in the cloud. IoT 1, IoT 1.
Okay, give me 2 seconds.
We're using our own web technology from the SCADA. So we've got a Droid running in the cloud, which allows customers to basically have a full SCADA system in the cloud and connect to you. All right, so
Please switch on your mic.
There it is, yeah.
There it is.
right, guys, we've turned the camera straight onto the screen, and I think you can see that. So what I'm going to do is I'm going to walk into this.
No. There you go.
Oh, it's in the presentation.
They're shooting you now.
From where?
There you go.
Yes.
Right, so we've had to hybrid this thing, and I think so. Can you see me?
Yeah.
Yes.
Am I there?
Yeah.
All right. So what you can see on the screen is it's sitting at blue. I've got a little button here. You see?
I can, but there's a delay.
Okay. What can you see now?
The screen will shadow inside.
So I'm not live.
Let's try hotspot. Can I connect to my phone?
Guys, just on the net, can you see Dave moving, or is he standing, or is he frozen?
He's frozen.
He's frozen.
Yeah, he's frozen. Eh?
Yeah, but- And it's also on the same net, that's why.
Yeah, this hotspot for your laptop on the phone.
Guys, I'm going to just put Lawrence onto a phone hotspot. And they've had their third beer and they're now sharing videos on WhatsApp
Okay, there we go.
on the Wi-Fi. Am I there now?
There you go.
See you now?
Now we can see. Yeah, and he's moving.
So if I stand there, you can see.
Yes.
Okay.
He's live.
I just had to disconnect because I switched over.
He's still alive.
Can you see that?
Yes.
Right. So I'm going to move very slowly. You can see that that's sitting on blue, that dot there. I've got a little button and I'm going to press the button and change the state. And so what this is going to do, it's going to transmit a Sigfox signal out from this building. It's going to be picked up by the network. It's going to be then relayed back to France, somewhere, server in France. Our Droid server is sitting, I think, probably locally in South Africa, with a callback from their sensors data sitting in France, and then relaying it back to us over the internet to this place. So there's quite a lot going on behind the scenes, and I'm going to change the state now. Well, let's just see how quick this is. I can almost guarantee it's under 10 seconds. So you can see it's on blue. I'm going to change the state by holding it in. So it's gone to purple. It's now transmitting. It's come back with a change of state here. So that was under 5 seconds for that to happen. So reliable, and will happen if I'm probably underground by 2 stories, it'll work. So the nice thing about that is you can put it in buildings in fairly hidden places, and it will still work. I'm going to show you that again. I didn't hear any oohs and ahs from the audience. So I'm going to change it again. Gone to purple. There's the purple at the bottom.
Wow.
So you can see, so that's Sickbox. I heard an ooh and ah from Lawrence, which is good. And we're going to show, so again, that's a little bit, I don't want to be harping on Sigfox technology, but it's good to monitor things like, you know, you can change of state. You can get a digital input that just picks up a motor running simply, or a flow switch. It's for that sort of data. Let's go back to the presentation and close it down, Lawrence. Yeah. We'll be back to this a bit later. Okay. Right. So you want to share that?
I'm going to share it now.
Am I in the presentation?
Yeah. You won't be. No.
I won't be now.
Yeah.
Okay. So are we there?
Yes.
So moving on. So again, there are various technologies you can choose to achieve certain things. And we have worked closely with a company called Polar Monitoring. It's a local small company to develop and release a portal which will allow customers to connect any Modbus device, really, whether it's a PLC, whether it's an instrument, whether it's any device. You can connect it, and we can bring it back to a portal that you can allow your customers to see and modify. So if you look at it, the architecture, you guys probably can't see this, but I'm showing. Basically what it is, it's a portal in the cloud which uses a 2G modem, and I think they are developing, they have an LTE version and soon going to have an Ethernet version, which will open up the world considerably. But at the bottom, it talks Modbus, so you can put it into any device talks Modbus. So whether that's a PLC, and most PLCs allow you to talk Modbus, whether it's a standalone VSD controlling in the field, maybe a farmer who doesn't want to move around, he wants to see from his bucky what's happening and switch stuff on and off. And any other instruments. We have also, as part of the range, a little RTU which allows you to bring in analogs and digitals and switch stuff on and off. Again, as part of the cloud. Solar inverters. If you want to be able to monitor your own solar inverter at home, although most of them do have some sort of cloud base, but if you wanted to put it on a SCADA system, a Droid in particular, it's possible. Or power meters that talk Modbus. Again, anybody who wants to offer that sort of limited monitoring of devices in the field. And then we've extended it slightly in that we can host a Droid in the cloud and talk to any of these devices from your SCADA system from a Droid. So you can now turn it into a PLC in the cloud. You can do control from the SCADA system directly onto a device. And that's been quite successful. So you can actually do machine-to-machine monitoring using this device. So I'm going to now demo this. Again, it's worth the demo, and Lawrence is going to pick up the camera to show us. What we have is we have a pump connected to a variable speed drive with our modem sitting there, connected to the server, which will allow us to use our Portal Connect app if you want to, as well as the Droid in the cloud. So we've got quite a lot to show here, and having to swap. We'll show it on the cloud first. I'm not sure how we're going to show it. Oh, the video we can show. It's probably just, it's probably worth saying just the app.
Just the app.
No, otherwise you can't do both. You can't. It's worth. All right, let's go. So you're actually monitoring the app, the
online. Yeah.
The online now. All right. All right, online demo, not done. Demo. Demo, no.
Let's up.
What's the next?
They see it then.
Right, so what we're doing here, guys, out there is we are connecting to the Adroit server in the cloud. Can you put this on here and show what we have?
I'm going to have to. They can't see both. So
That's what I said.
To stop and.
All right, okay.
That's fine. So what I'm going to do is I'm going to stop presenting and then.
Well, we'll show this first,
Okay.
and then we'll show the result, and then we'll go onto the camera and we'll show it working on the phone. Product information. The guys sitting virtually will have to take our word for it when people start clapping when the motor starts. That it's actually running, okay? VSD monitoring. All right, so what we have here, we have a live setup here with a motor and a VSD and our Connect modem. And what we're going to do is press this button here that says start.
Well, they'll hear it, so.
Yeah.
Oh.
They can't see that. Yeah, they can't. Right, so, and then also I can change the value. So let's change the set frequency to 50, and you'll hear it go up. Again, more clapping, please. So we change that to 50. So that's communicated from the cloud via the Connect portal in the cloud through the API down through Modbus onto the device and change the speed. So, and of course, you can stop it. And then what we'll do is we'll go into the camera and I'll show it to you working on our app as well. I'm going to just get it up here. Okay, so you can go into the camera now.
There you go.
On the camera.
Yeah.
Right, I'm on here. Can you show this? No. What can we see? Can you see it? Can you see that?
Yes.
Oh, there we go. So I'm going to show you this. We're on the app on my screen. I go to devices. Excuse me, I'm a bit blind. Put my glasses on. You'll see here there are 3 devices. We're going to go to the Adroit demo here and go to the dashboard. You'll see I have a full dashboard showing the motor, the DC power, etc. And what I'm going to do, you can see that the status says stopped. You can see the motor is stopped. Can you see the motor? And I'm now going to press start, and that goes out from my app. And there's clapping from the audience and clapping from the virtual. And of course, you can see the history, you can see the trend, what's happening with it. But if I can also want to set, I can also program. I know the parameter to change the set point is 13. I can read the value from the drive. You can see it's set to 5,000, which is 50 hertz. Let's change that down to 40 hertz. And write the value. Sorry, I'm going to press the wrong button. I'll just go through the exercise again. So I'll go to parameter 13. I'm going to read it. Change it to 4,000. Write the value. And I can hear clapping. So again, that's free by itself. You don't have to take the Adroit scaler. But again, that's and then of course there's the ART which you add in as part of the Modbus RTU or the communication from the device, so that you can extend the application into reading some I/O at the same time as changing values from the PLC. So we're going to go back to our presentation now, just to wrap up. Sorry guys, this was a little bit more difficult than we anticipated. Are we back up?
Yeah.
So stepping through now, just to give you some idea, you've got various options and a 1 year for the basic portal, including your app, is right $5.5 grand, and it goes up to 10 grand if you want to now have the app and the SCADA to monitor some device in the field. So very typically used for any OEM or that you want to monitor some devices in the field. Very simple. I won't go through that, but essentially, again, it's about managing data, and you can choose 2 versions, either the 30-minute poll times or the 5-minute poll times, and that just changes the cost from a point of view of how much data you're going to be putting through the portal. But again, if you have any applications and you want to talk to us, you can. So just to wrap up, I want to say thanks to the SAIMC. This is a very interesting space to be. We all want to monitor stuff, and it's not as trivial as it is. Often we get locked into either a supplier or a device. So then we've got millions of apps, whereas the Modbus is generally a very universal communication protocol available on plants, on devices, on instruments, etc. now, and you can now bring all that data back onto the web and have it on your phone. So if you have any applications, I think it's an interesting space to be in. Please feel free to come and talk to us about it. And I want to thank the SAIMC for giving us this opportunity. And it was a privilege to be the first guy to present post-COVID in a hybrid environment. Thank you. Right, so I think are there any questions? Okay, so we've got a question.
On your pricing, so if you can go back to that slide, you said roughly about 10,000. Now, how would it work in terms of tags? How many tags do you get?
Okay, so again, that would be, we've worked that price on about 50 tags.
50 tags, but level tags.
No, analog or digital. It makes very little difference. So, but again, just remember, okay, with these things, they are not generic like a SCADA system where you can just set up communications. You need to know what you talk to, because they've got to develop that side of the communications, bring it into the portal, then we can bring it up to the SCADA system. So it's not as flexible as a SCADA system connected to a PLC. It's really for devices and known amounts of data that you want to bring back. So an energy meter, if you want all 3,000 values, it's going to be different. We work a generic price on about 50 tags per device.
So you can't, for instance, have one master and 10 different machines on 10 different locations, and then create your own dashboard.
No, you can do it on a Droid. You can use the Droid in the cloud to do that if you're familiar with the Droid. But the dashboards themselves, built by the Polar guys, are quite fixed in their capability in terms of how presentation they are. For that very reason, it's not a SCADA system. It's a fixed thing that you want to monitor and poll every 10 minutes or so.
So monitor and control on that.
You can do monitor and control. You saw me change the variables with the speed up.
You mentioned Modbus. What happens if you got something that doesn't use Modbus? Or are you looking towards that? Or?
The problem with that, Eric, is that you then have to develop the protocol for those devices. And that's a whole different animal that you don't want to get into. So what we are doing is that technically what we've done here is we've wrapped our Modbus driver that knows how to communicate through their modem directly to a PLC. We can extend that wrapper onto any of our drivers. So technically, you can use this modem. You probably couldn't use the portal. You'd have to then bring it up to the SCADA system.
Any serial comms.
Any serial comms. Any serial comms, we can use our driver, but then you'd have to use a Droid. So otherwise, they would have to develop the serial driver for that device. So it's not impossible. Not impossible, again.
No, it's just that it seems like the Oriental manufacturers are still often Modbus. whereas like Siemens and places like that don't. And so Mitsubishi, Yaskawa, that type of guys will often Modbus.
Well, I think I stand to be corrected, but I would imagine most Siemens VSDs will offer you Modbus RTU as an interface.
Yeah, if they've got an Ethernet port, the odds are 90% of them will be able to have Modbus, because Modbus is the backbone for most of those.
Yeah. So I know most of the drives do have a Modbus interface. So for example, okay, you've done it for Chinese drives.
Yeah.
In the
Right. All of them.
all of them have Modbus.
If they don't have Modbus, they have a card you can buy that gives you Modbus.
Yaskawa, Mitsubishi, they tend to use Modbus quite widely.
The problem, of course, is that they are all moving to standard Ethernet and not serial comms anymore.
Yes.
So that's why these guys are developing an Ethernet mode.
Another option is the RTU as well, to go basic. If it's something that doesn't have any comms, you can monitor the parameters via RTU.
So we can put this on top of any other PLC that allows you to have RTU comms.
Dave, we've got a question online. I hope I pronounced correctly, from Thomas Holtz. Thank you. Very interesting. In your professional opinion, what do you believe will be the skills required for IoT in Industry 4.0 in the future going forward?
Sure. So it's IT skills, because it's about getting this data. We're about to launch our Edge gateway, which basically you put an Android down, you can talk to any of our drivers, you can take any data and put it straight into an IoT cloud. Once it's in that cloud, you need those skills to be able to build the dashboards and the reports and stuff. So the skills of the future are the guys who know about cloud services, programming, .NET. It's programming. It's programming.
Okay, and if I can just make a comment there, it doesn't take away from the on-the-floor skills.
No, not at all. Not at all. No, again, which portion of Industry 4 are we talking about? I mean, I know Thomas, you know, the application engineers on the floor are going to be the hybrid guys who know about PLCs and comms and cloud and security. You know, it's going to be a big ask of these youngsters in the future. Big ask, because you still need to know about ladder logic. You still need to know about basic control philosophies. Okay, to find that. So I think the two are still segmented, and I think they're going to be segmented for a long time, because the individual that knows how to do control in a dirty plant, okay, is generally not going to be the guy who's going to go and program in the cloud. The two are separate, and I think they're going to remain separate until those skill sets. And we are seeing instrumentation engineers coming out now that can do programming of stuff in the cloud. We've just employed two young black guys who for that reason, they've done their instrumentation tech, but at the same time they've learned about cloud, because it's going to come that all the data is going to sit in the cloud. I don't know whether SCADA is going to go up there yet, but I'm not saying no. But
okay, another question from Andre. How dangerous is this? If I have my hands on a motor shaft and you press the start button from the bucky, could that be painful?
I would say it can be more. Yeah, listen, it can be more than painful. So there are a couple. In fact, we've had experience of this, because we were doing this test at Franklin Electrical on a pump, and I had selected the wrong demo version, and I started the pump, and we got a call within 30 seconds to say, guys, what are you doing? So it's enormously dangerous. So the interlocks. You still have to have the safety interlocks in place. You still have to have the lockouts. You still have to have security involved that allows people who are logged on to be able to do it with maybe verification. It's a massive problem. It's a massive problem.
With respect, it's no different from any automated plant where a motor can stop the plant when you can. So it's a basic safety culture.
So I'm guessing an answer, if you're going to stop and start a plant in the veld. Now farmers probably don't care about this stuff, but technically what they should do is put a modem there with a little siren that sounds the siren for 30 seconds and then starts the rotor. typical plant safety stuff.
So it's like a
Or
time,
lockout
a time
procedure,
switch.
the guy doesn't want it to stop.
Or a lockout procedure, yeah, but it's a real problem remote.
If you look at it, I mean, you no offense, but you're looking at old school technology. The right way of doing it is to look at the artificial intelligence level of it and have an IP camera there. They can distinguish that the area is safe to start mode.
Yeah.
That's where industry is going.
Yeah.
They have a lockout, it's ultimate. Nobody's going to do that anymore. You've got computers and artificial and algorithms to make the decision whether or not to shoot that on based on one or more conditions.
I mean,
That's where
for $2,000 you can buy an IP camera now that puts, and I can see on the cloud, how long that's going to last in a pump station on a X farm? Not very long.
you can think, thank COVID for a lot of this technology. We've commissioned how many machines virtually by means of having an IP camera on the machine.
Yeah.
We can then physically see the movement, we can see whatever is happening, and remotely via a secure tunnel, we can commission those machines.
And of course, there's digital twins, there's all that stuff that's coming through that allows that to happen.
Okay, so we've got time for a last question. Does anyone want to go?
Was that interesting, guys?
Yeah.
It's always tricky to pitch these things from a point of view of tech.
Everything looks good online. So.
Yes,
You said at the beginning when you were talking about Sickbox that it was one-way communication. Is there a plan to turn that into two-way communication?
well, it is two-way communication, but you can only communicate to the device 4 times, depending on what plan you're on, 4 times a day. So it's not ideal. If you want to open a valve, and you've opened it 3 times, 4 times already, you've got it. So it's not for that. There are better technologies for that. If you're going to do that control, it's really for monitoring.
Okay.
All right, good. Guys, thank you very much. 7 o'clock. Beer time.
There's a lot of thank you. Very cool, brilliant, awesome. Thanks, Dave.
And those are all my employees. Can you take us name down? Salary review coming up.